Hello and good morning, everyone. Welcome to this webinar on OnRobot DPLOY. Thank you for joining us this morning amidst your busy schedule. The session today will focus primarily on OnRobot DPLOY product, focusing on the solution, the offering, and specifically on machine tending and on packaging. So this is what we will focus on. I'd be happy to introduce our speakers for the day. I myself, I'm Shiv Kumar. I'm the COO at MELS, heading operations here. We will have speakers from OnRobot based out of the Asia Pac headquarters at Singapore. We will have Mr. Niels speaking to us. So Mr. Niels is a native Dan who has spent over 25 years abroad in different parts of the world. During his studies and work assignments, Niels currently is based in Singapore, joined OnRobot in October 2017 and was their first employee in the APAC region. And he's in charge of OnRobot's partner network and business development across South Asia, Southeast Asia, and Oceania. OnRobot is the global leader in end-of-arm tooling for collaborative and light industrial robots. Niels holds a bachelor's honors degree in marketing and international management from the International Business School, Groningen, the Netherlands. During the past 22 years, Niels has worked for various SMEs and international companies in Malaysia, Singapore, Denmark, and Qatar, as well as has run his own consultancy firm for a period of 6 years, where he worked with and invested in startup companies in Malaysia and Singapore, as well as taking on consultancy jobs for local and foreign industrial clients. These have been working with primarily the industrial sector, selling technical services and products directly to end users, as well as through distributors and agents. OnRobot APAC currently has partners in 15 countries and territories, where Niels personally handles 10 of these markets. Niels will also be supported by Branson. Branson Lee is from OnRobot. He's a technical support staff based in Singapore, covering South Asia, Southeast Asia, and Oceania, and has been with OnRobot since 2019. He is responsible for pre- and post-sales support and managing technical inquiries and issues. Branson has 12 years of experience in the semiconductor industry, servicing and performing installation and setting up of different brands of wafer handler robots for different equipment. I will now pass on the floor to Niels for him to present OnRobot DPLOY solution. I request all participants to stay on mute. If you have any questions, feel free to type them in the chat box or in the Q&A section. And we would have a separate Q&A section where you could raise your questions at the end as well. But feel free to post your questions on that. Okay, thank you very much. Niels, over to you.
Yeah, thank you very much, Yuva, for the very nice introduction. I will all right. Can you guys see my presentation?
Yes, we can.
Okay, good. Hang on, I think this is the wrong one. Just give me a second. Sorry, guys, I just have a problem opening this. All right, we'll stick with this one then. Some issue with the other file, but it should be okay though. So today we will be talking about a new solution coming from OnRobot, which is called DPLOY. Basically what we call it the first platform to automate deployment for collaborative applications. And you'll understand more about what that means when we go a little bit forward. So the way we're going to do it is I'm going to talk a little bit about the reasoning for developing deploy, the kind of benefits that deploy will give a manufacturer in particular, considering the complexities and so on. You will often find with doing, let's say, traditional implementation of robotic applications in industries today. And then towards the end, we will, my colleague Branson will show you the platform, basically how you can set up a complete application with absolutely zero programming and something you could do in maybe an hour or two rather than potentially a week or two of doing programming for applications. So if you go back over the years, doing deployment of robotic automation, of course, has become easier over the years with cobots and so on and so forth. But the fact is that if you set up, even with a cobot, if you set up a full application, this could be, for instance, CNC machine turning or palletizing, it is still not that that easy or that fast to do. There's still a lot of programming to be done. There's still a lot of complexities. There's not necessarily a lot of flexibility in using these kind of traditional automation setups. So this is major reasons why, if you look at things like CNC machine turning and palletizing globally right now, we're talking maybe 5 or 7% of all applications globally are automated. So more than 90% are basically not automated, exactly because of this reason. A lot of companies just find it too complex, too expensive, too time consuming, and not flexible enough. And this is kind of what we want to overcome with Deploy. Just to give you a bit idea what OnRobot is traditionally known for until recently is basically supplying different kind of tools or different kind of end effectors. So you can see here a list. We have a lot of different grippers. We have force stroke sensors, vision system. We have some processing tools like screwdriver, sanding tools, quick chainsaws. We have our lift, 7-axis lift for things like palletizing. And then we have Deploy, which is basically a software solution, which is what we are talking about today. Quick thing just to add on here is that everything we do is electric. We don't touch pneumatic. We don't do anything pneumatic. So all our tools are basically plug and play, as it's called, or plug and produce, as we like to say it. Now going back to kind of the history of automation and robotics in particular. So all of you are familiar with the industrial robots. This is the first kind of robot that came out, many years ago. Big, complex, expensive, dangerous, typically used in automobile sector in the beginning. Of course, now you see industrial robots in many different sectors, but still today it's quite complex still. It's very difficult to program and so on and so forth. So industrial robots, as good as they are, they're not the most straightforward when it comes to implementing different applications. Then about 14, 15 years ago, we had the first cobot coming out. Of course, there's a ton of different brands of cobots today. As you know, one of the best brands in the market is Doosan, which is sold by Mel's. And with cobots, things became easier when it came to introducing or installing applications. Programming became easier. But the thing is, even with the programming being easier, when you actually go in and setting up an application, it is still not that straightforward. There could still be weeks and weeks of programming to be done. After the cobots, you had companies like OnRobot coming, with the collaborative and very flexible tools. We have from OnRobot side what we call one system, zero complexity. So basically any of our tools can be installed of any robot brand, any robot model in exactly the same way, with the same way of programming it. So basically when you see here the line, going down, that the easier things become, the less programming is needed, the less setup time is needed, and so on, which is where we're coming to Deploy, where basically what you can do in 1 or 2 weeks, we can now do in a few hours or in a day maximum. So deploy for manufacturers. Why? Why did we do this? So I don't know the background of those of you who are attending today. Maybe you're already doing some robotic automation. Maybe you've never done it before. But either way, the fact is that once you want to go into robotic automation, the investment cost typically is still quite high. Why? Because there's a lot of complexity. The deployment time is typically very long. So you know, time is money. So every hour you spend on programming something or setting up something is very costly. Another thing, especially when it comes to SMEs and especially when it comes to high mix, low volume production, is that the traditional applications today are often lacking flexibility, right? So high mix, low volume things like CNC machine tending, for instance, sometimes palletizing again. You know, every time you need to change a workpiece or every time you need to change a box size for palletizing, it means you need to reprogram potentially a full application. It takes time. It takes man hours. It means downtime where your setup is not running. So again, very, very expensive. Another thing is that today there are certain software platforms where you can, let's say, replicate a specific application you want to do, but bottom line is that until it's actually installed in your production, you don't know whether it's going to fully run or whether there's going to be certain issues and so on and so forth. A software cannot tell you that. It can give you an indication, but you don't know until it's installed. So there's certain risk to the way things are done today, especially when it comes to new technologies and so on. Another reason that many companies, and again, I'm specifically referring to SMEs here, is that many companies today don't have, let's say, the right technical competences in-house to feel confidence in using robotic applications. So if you're, let's say, a SME with maybe 50 people, maybe you have a lot of management people, maybe you have a lot of workers, but you don't have a lot of engineers, or maybe no engineers that knows anything about robotics or programming and robotics. So again, that kind of holds a lot of companies back because they're afraid of, you know, what if we put in robots? You know, we need SIs coming and helping every time there's an issue, every time we need to reprogram something or change the workpiece. You know, we can't do it ourselves, and we need SIs to come and do it for us. So again, lack of flexibility. In terms of project lead time, same thing as I said before. It can be weeks, it can be months sometimes. Sometimes you need to program, you need to reprogram. There's a lot of, you know, once you set up the application itself, you know, there can be issues that you didn't think about to start with. So the project lead times can often be not only long, but also very uncertain. And again, if you are having a project where you need something set up very fast and you want to make sure it works, then these are things that, you know, for a lot of manufacturers today are holding you back from actually going into automation, which is a big shame. So when it comes to deploy, what does deploy bring you? I briefly mentioned earlier on that it basically means no programming for setting up application. But one of the key things that we are really offering is a huge time saving in deployment and redeployment. So here's a few examples, and of course these hours we're mentioning here can always be argued again whether it's longer or shorter or whatever. But these are kind of rough average hours that we have discussed with many of our system integrators around the world. So if you look at palletizing as an example, kind of an average setup for palletizing application with a standard robot, and it doesn't really matter whether it's a cobot or industrial robot necessarily, but an average setup is about 40 hours. With deploy, you can do that in 4 hours. So basically 1/10 of the time, right? So that is great for you if you're a manufacturer. Of course, if you're a system integrator, which some of you might be, that also means that you can do 10 times the amount of projects with the same amount of people that you're doing now for one project. CNC machine sending, which is another great example, an average setup is about 36 hours. We can do that in 6 hours. And when I talk about setup, it's setting up the robot, installing the gripper, doing the, in traditional way, the programming, but for us doing the setting up the application itself. So about 1/9 of the time that it takes to set up a traditional application, and so on and so forth for packaging and transferring. But one thing which is very important, because a lot of people, when you do ROIs and so on, you just look at, okay, how long time does it take to set up? You often forget about all the redeployment that might be in your application. As I said again, palletizing is a great example. CNC machine sending, high mix, low volume is a fantastic example, where you might be, you might have small batches of 100 units, 150 units, 50 units, whatever it is. So every time you change a workpiece, that means you need to do some reprogramming and reset up of your application. If you do that with a traditional robot, whether it's cobot or industrial robot, that means a lot of programming time. With deploy, you don't need an SI to do it. You can do it yourself, and you can do it very, very fast. So the downtime is very minimal, and the training and being able to understand how to do it yourself, you don't need to be a robot programmer to be able to do that. So you can actually have your own staff learning how to redeploy applications. So there's a lot of benefit in this. And of course, the more you redeploy, the more time you save, and the less downtime you have. So the faster ROI you will have as well. So in so many words, you as a manufacturer basically will gain control of your own automation process, your own changes. And what you see here, these pictures basically is and you'll see this later on, it basically shows a picture of how the deploy application looks like. So what we do is we empower you as a manufacturer to basically control your own journey. If you have your own people, you might even be able to set the application up yourself. And if nothing else, you can definitely learn how to do redeployments on yourself, on your own, and you can save a lot of time and you can save a lot of money on that. What is also part of deploy is a monitoring tool that it comes with deploy. So basically you can monitor things like cycle time, how many pick and plays are there. You can compare maybe one shift to another shift, 1 week to another week, or you can get the warnings if the application is down, and so on and so forth. The whole automation setup is much faster, so you save time. And if time is an issue in terms of setting up the application, you can do it much faster with deploy than standard setup. You are less dependent on employees. So we all know, and I'm sure that's the same in India, if you have good employees, they are not necessarily very easy to retain. So if you're a manufacturer and you have a guy you have spent months on getting trained to, let's say, being able to program a specific robot brand or a specific robot model, and he leaves, you are in trouble sometimes, suddenly, if he leaves, right? Because you need to find somebody else, you might need to retrain them and so on. Whereas with deploy, we work with different robot brands, and regardless of the robot brand, the implementation is based on in the same way. So in that sense, you will also reduce the training hours needed of your staff. Another way of empowering manufacturers, and then this is basically a quote from one of our own system integrators that are mentioning, once they do, let's say, the traditional integration they're doing today, one of the hard points to sell, and one of the feedback that they're getting from the end users is that they are not really interested in getting very complex programs, so maybe thousands of lines of programming that they have no clue how to change themselves or how to modify themselves. And if they want to do it themselves, there's a lot of training to be done, and so on and so forth. So having something like deploy, which is very easy to use, very easy to learn, and very fast to do, is a big benefit for them as well as you as an end user. So just a final recap here. Deploy will help you as a manufacturer to basically break down those different kind of barriers that are there today in terms of, you know, flexibility, setup time, training, and so on. We can give you dramatic time savings in both deployment, but also redeployment, which is equally important. So of course, that comes at a lower cost over time. You help save your labor shortage problems. I know automation in general does that, but of course, doing it with deploy will also help that. We will help you improve productivity, relieve operators, and so on and so forth, which is similar to what robot automation does anyway. But ultimately, we give you the option to take control of your own journey in terms of the automation process, what you want to do, when you want to do it, how you want to do it. So deploy itself, how does it work? So again, as I said earlier, later on, we'll just show you the platform itself, how it looks like. But basically, deploy is a cloud-based platform. We don't call it a software. Ultimately, it is. It's a mix of hardware and platform, but it is cloud-based. So as long as you have an internet access and as long as you have a browser, you can basically set up a full application, whether you have a mobile phone, a tablet, a laptop, a PC, it doesn't matter. But just via your mobile phone and internet connection, you can set up a complete application, whether it's CNC or pick and place or palletizing in a few hours. So it's cloud-based, as I said. The way it works is there are 5 steps, and I'm not going to go too much into this because my colleague Branson will show this later on, but there's a few different steps you have to go through. So I'll let Branson explain that. A few key things, as I said, what you need to do is you need Wi-Fi or internet when you set up the application, but you do not need Wi-Fi or internet when you run the application, unless you want to do the monitoring. So you don't really need to worry about, losing connection and suddenly your application doesn't run. There's no issues with that. You can still run without having an internet connection. And I know some of you might worry about security, but we have done a lot of measures to guarantee ultimately maximum security. There's a white paper which you can download from our website to know more about the security measures. So I'm not going to spend too much time on this because we are limited time to do the presentation today. But in terms of backup, so you have your local backup, you have cloud-based backup. So again, there's a lot of safety features based on this as well. Just the last couple of slides from my point. As I said, deploy is basically a mix of hardware and software. So we have here what we call the OR base, which is kind of the brain of deploy. So OR base is where you connect the robot, you connect the grippers or whatever tools you're using. You connect whether you're using, for instance, a CNC machine, or it could be a conveyor for palletizing and so on. So all these things are basically connected to the OR base. We have an OR machine, which is basically if you have additional IOs that need to be connected, or other digital analog signals that need to be connected. So that's an add-on you can use as well. And we have OR-COM. So sometimes there might be a ban on using your own internal Wi-Fi from the company. So you can, for instance, use the OR base and go via GSM connection. So basically buy a SIM card and you can use this to set up. So these are the different tools we have. In terms of deploy, look at it as maybe Windows is a good example. So for those of you that are my age, you might remember Windows when it came in initially, the first version. Windows today and Windows when it launched are two very, very different things. So deploy is a platform that will continue being developed. So currently we are having 4 different applications that we work with: palletizing, packaging, transferring, which is basically pick and place, as well as CNC machine sending. But every few months we'll add on additional applications. We will update and improve existing applications. We have a different range of different supported robot brands, but those will also be added on. Like one of the next one will be Yaskawa coming on, and so on and so forth. So it's a continuous process of applications that are being added on and integrated, and more robot brands and models coming on. And it's also important to mention that this is, even though we're talking about collaborative applications, this is not only for cobots, it is also for industrial robots. So you can basically set up an application as fast and as easy with an industrial robot as you can with a cobot. Last 2 slides on my side before we go to my colleague Branson. So if you want to know more about Deploy and want to learn a little bit more about it, you can basically go to our website and www.onrobot.com. And from there, there's a link to something called Learn on Robot, which is kind of like a training platform that also explains more about how to use Deploy for different applications and with different tools and with different robot brands. So I urge you to go in and have a look at that, also to learn more. So this is the last slide from me. I will now hand it over to my colleague Branson to show you how Deploy operates and how it looks like.
Okay, hi everyone. Just give me a second to share my screen. Okay, I think you can see my screen. Okay, so in terms of deploy, so as what Niels has mentioned, we have 5 key steps for you to actually accomplish the whole applications. So I will not go through too much in terms of the access level. So just note that we have a admin, a manager, and a operator access level. So to cut it simple, the operator access level can only start and stop the program, whereas the admin and managers have similar roles. The only difference is that admins can add more admins inside. Okay, so let me just quickly log in into the deploy interface. Okay, so once you have logged in into deploy itself, this is what you will see. Okay, this is the standard deploy interface. Okay, no matter what applications that you are using, be it CNC, machine handling, palletizing, packaging, or pick and place, it will be the exact same screen. Okay, so the first step in order to for deploy to actually be used, okay, with what we call is the automatic component discovery. So what this means is, once you've connected the OR base to the robot and all the grippers connected up, okay, you can see that Deploy automatically detects what grippers you're using, the robot brand and model that you're using as well. Okay, everything will be automatically known. Okay, and then once all this has been showed up, okay, all you need to do is to set up the gripper. So for this case, as you can see in our simulated CNC cell, we have a dual setup. Okay, so I'll just roughly show you. So one of the grippers, you can just actually easily just configure, choose your setup, okay, the default setup, and different OnRobot grippers will have different kind of settings. So you just choose the finger orientation, for example, and the accessories that you're using. Okay, so once that is done, as you can see on the interface here at the top here, you can literally control the gripper opening and closing directly from Deploy itself. You do not need to go through the teach pendant at all. Okay, so it will be the same thing for the second gripper, just to show you quickly. So different OnRobot grippers will have different features. So as for this particular gripper, it has more features, so just choose accordingly. And same thing, you can also control the grippers directly from the Deploy interface itself. So once you have set up all your grippers, okay, next we go into the robot. So once you go into configure, you can see here it knows the robot brand, the robot model. Okay, all you need to do is just to key in the IP address of the robot and connect. Okay, once it's connected, you can pretty much jog the robot from Deploy itself. So you can see over here, we have the XYZ coordinates and we have the rotation XYZ coordinates as well. Okay, so everything can be controlled by here. Okay, you do not need to go through the teach pendant and then go back into Deploy again to finish up the whole application. So for those robot brands that has free drive, for example, like the Doosan or the UR, okay, you can activate the free drive from here as well. And then as per normal, use your hands to move the robot's position. All right. So once you have set up once you have set up the robot, okay, just make sure you set a home position. Okay, it's the same thing. If you go into teach, you can see the exact same interface. Okay, once you have teach the home position, and you're pretty much done with the robot setup. And then next we move on, we have the digital inputs and digital outputs. Okay, as News mentioned, on the OR base itself, we have you need to manually connect the digital inputs as well. So for different applications, okay, we will have different slightly almost similar, okay, inputs like the sensors and stuff. But for CNC, we have this special input called CNC machine. Okay, I'll just show you what it is about. So when you choose the CNC machine, okay, we ask you to choose your CNC type. Okay, be it the milling machine or the lathe machine. So for this example, as you can see here, we are using the lathe machine. So all you need to do is just to key in the chuck's dimension. Okay, you can see over here in the graphics, just follow accordingly. And then teach the outside of machine position, okay, or standby position. Okay, moving down, we have mandatory functions for the CNC. So in order for CNC to work with deploy, okay, you will need these three mandatory signals, okay, which is the start program, end program, open your work holding or your chuck, and close your work holding or your chuck. Okay, so how do you actually set up all these signals? So it's pretty much just the IOs. So from your CNC machine, just map your signals to the OR base outputs. As you can see here, you can choose whichever signals that you are connected to. Okay, and then just select accordingly your output types and whatever settings that you need. Okay, so program start, program end. Okay, and then for work holding will be the same. Open work holding, and then your close work holding. Okay, so it will be pretty much just controlling, setting up your signals. So on top of these mandatory functions, we do have additional functions of signals that you can actually connect to. One of them is the most commonly used for CNC is like opening and closing of the door. Okay, but do take note that we only support automated opening and closing of the door. Okay, if you are having the robot to open and close, this function here will not work. Okay, and then we also have like tailstock advance and tailstock retract. Okay, we even have the machine self-cleaning as well. Okay, and then we do have other functions like robot online, offline, alarm, robot operation in progress, so on and so forth. Okay, so all these are additional signals that you can actually use. So once you have completed the mandatory functions and whatever additional functions that you have, okay, you're pretty much done. So at the top here, you can actually see, you can actually do an opening of the door, closing of the door, opening of your chuck, and also closing of the chuck. So it depends on what you have add on, you can actually control them from the deploy interface itself. So you don't have to go to your machine and open the door, close the door, come back to deploy again. It can be controlled directly from the interface here itself. Okay. So once this is done, of course, you can add more devices. For example, like in-feed container, out-feed container, in-feed sensors, out-feed sensors. Okay, but for CNC, if you are using in a tray, your in-feed and out-feed is in a tray, the sensors will not be applicable. You do not need to add any sensors because deploy will automatically know how many parts is there and how many parts has been completed. Okay, so as you can see here in this setup, I only created the CNC machine. And then for the digital outputs, this is also optional. Okay, so for digital outputs, as you can see here, we have a generic output. Okay, so the generic output is for you to create an output signal. For example, if you pick a part and the parts suddenly drop, okay, then you can have this event happening that shows, okay, parts drop, I will trigger this particular output. Okay, so this is the generic output device. And then another one is for machine cleaning, robot machine cleaning. So you should be able to see on the screen itself, on our setup, we do have a simulated robot blower over there. Okay, so this machine cleaning is actually meant for that. Okay, so we have robot cleaning and we have machine cleaning. So both are different kind of signals. Okay. So once you have set up, so just let me show you. So it's the same, pretty much the same thing. Just choose the correct outputs that you have connected to on the OR base, and then you're pretty much completed. Okay, so this is the first step of deploy, which is the automatic component discovery. And then we go to the second step, which is what we call the workspace definition. So at the top right corner here, where you can see workspace, once you click into it, okay, you can actually see this particular, let me just enlarge it a bit. Okay, you can see this particular 3D model over here. So deploy will automatically know the reach of your robot based on the model and the brand, including the including the grippers that you have connected to. So this dome over here is actually the reach of the robot, including the grippers itself. So if you can see from our setup, this is exactly what it is, what it looks like. So you can see that the obstacles that we have placed here are all labeled by numbers. Okay, so you can easily troubleshoot them if let's say there's some issues during the path planning. So there's one portion here which I want to highlight is for this number 6 over here. Okay, you can see here at the bottom where my cursor is. Okay, it shows the type. So you can see here you can create obstacles and you can create a CNC door. So as I mentioned earlier, as you can see in our setup here, we do not have a CNC door, but I actually created a workspace for the door, but I set it as a CNC door. So what does this means? So if you set it as an obstacle, okay, when you're doing the path generation or the program generation, okay, deploy will automatically avoid this particular obstacle if you have set it as an obstacle. But if you set it as a CNC door, okay, when the door is open, okay, deploy will know that this obstacle is gone. So the deploy the robot will be able to move in to the cell and then place the chuck, load and unload the chuck from the chuck. And when the door is closed, okay, then deploy will know that this is an obstacle and I will avoid planning my motion of the robot to be near the door itself. Okay, so all the obstacles that you have placed around here, okay, deploy will avoid during the path planning. Deploy will automatically avoid all these obstacles. Okay, so this is what we call the workspace definition, which is step number 2. Okay, the third step is what we call the application input. Okay, so for the application inputs, as you can see here, we go into this, we have step-by-step inputs from here. So it's pretty much following the same flow as how you would program a robot to move. Okay, so first thing is the gripper setup, which you don't have to do it because it's already completed from the first step. Okay, so just to show you that you can see that it's already chosen correctly. Okay, second step we have is pick from infeed. Okay, so like how you would normally program, you'll pick your parts from the infeed. Okay, and then you go into cleaning, optional. As you can see, it's optional part. So let's just not talk about the optional part. So after you pick from your infeed, okay, you will load into the CNC machine. And after you load into the machine, you unload. After the machining is done, you unload. And after you unload, okay, it will go into the you place back into your outfit. So you just it's the exact same motion, exact same way of how you program a robot, but this time everything is just purely inputs. You do not have to teach. Sorry, you do not have to do any actual programming at all. So just let me quickly go through. So what does pick from infeed does? So since we're using a dual setup, okay, you have the option of which is your loading gripper, which is your unloading gripper. Okay, and then you choose your raw part shape. Okay, is a cuboid or is it a cylindrical? But this doesn't mean that we can only pick these two kinds of shapes. Okay, it means that even you have some weird or funny looking shape workpiece. Okay, the place where you're going to pick the parts. Okay, just choose the closest shape. Is it more of a squarish or more of a circular? Okay, that's the meaning of this raw part shape. So once you have chosen, okay, you select your infeed type. Okay, we have the grid type, we have the honeycomb type, and we have the fixed. So fixed meaning if you're coming in from a conveyor, okay, and then there is called a fixed position. So you can have option. So for this particular case, we are just showing a grid. Okay, and then you can choose the number of rows and parts per row. So for simplicity's sake, we just choose 2 by 2. Okay, and you have also the option of having stacked parts. Okay, how many layers of your stacked parts will you have? Okay, so once you have input all the correct numbers over here, okay, you will see it will generate this 2 by 2 graphic over here. Okay, sorry. So just scroll down and then just follow the instructions again. They will ask you to grip the part and teach the pattern location. Okay, so you can see grip part and teach the red, and teach the blue, and teach the green. So you can go up to this. You can see here red, blue, and green. It will always be in this anti-clockwise motion. And you can also actually adjust where you want your number 1 to be. So you can see here the numbers represent the picking order. So if you want your picking orders to start from here, then you can teach from here. If not, you can just rotate it however you want your first part to be picked from. Okay. So once this is done, next is select your gripping orientation. So depending on what kind of workpiece, you can have external grip, internal grip. Okay, depending on the gripper itself as well. Key in your raw parts dimension following the graphics over here, the A, the C, and the D, and then your parts weight. Okay, we do have an expert mode over here, which we'll not really go into due to time constraint. Okay, once it's done, we have this thing called, we have this extra part called part alignment, or I would say a regrip station. So this is optional as well. So if you need to regrip your workpiece, you can also enable this part alignment step. Okay, but we're not going to do this for now. And then next we add on, I have added on the optional robot cleaning. So as you can see here, you just teach your cleaning point. Okay, you can add multiple cleaning points as well. Okay, so once that is done, it's completed. And then the next step is load into machine. So load into machine pretty much just teach your load position, and then teach your load approach, and then exit position. Okay, so once that is done, we move on to another optional option, which is the cleaning again. So before the robot will pick or unload the workpiece, it will do another cleaning of the workpiece in the machine itself. Okay, once that is done, we have unload from machine. So unload from machine, we have the option of you using the same as your loading machine loading position, or if you want, you have a new unload position. So for this particular case, because we are using a dual setup, okay, definitely we are not able to use the same load position. So we have to use a new unload position. Similarly, choose your selected finish part shapes. Okay, sometimes you go in as a cuboid, and then after machining, you come out as a cylindrical. So we have the option of choosing that as well. Okay, and then teach your unload position and your unload approach and exit position. And then same thing, your grip orientation, and then the parts dimension, the A, C, and D, and the finished parts weight. Okay, once that is done, then the last thing is we go into, and if you have another regrip station, then you can actually add another regrip station over here. And if you do not have it, then the last step is to go into place onto outfit. So place onto outfit is pretty much the exact same thing as pick from infeed. Choose your outfit type. Okay, you can have same as infeed, grid, honeycomb, or fixed. So same thing, 2x2. And if you have stacked parts, just go ahead and create the stacked parts. How many layers? Okay. And similarly, teach grip the part and teach the red, blue, and green. We do have the option here of changing your place path, how you want the sequence to go. Okay. So once that is done, okay, you're pretty much completed. And then the third step, what we will call is the path generation. So at the top here, we have this thing called finish setup. So when you click on finish setup, as you can see here, the program generation in progress. This is where the magic happens. Deploy will automatically do all the programming out for you, or the path planning for you. So which means based on all these inputs that you have keyed in, okay, deploy will automatically plan the path for you for the robot to go from infeed to robot cleaning to loading, unloading, robot cleaning again, and back to your outfit. So every single movement will be planned out by deploy, and it will also optimize the path planning of the robot as well. It will try to go the shortest possible path to reach or to finish this whole application itself. Okay, so the fourth step is completed. And then just one more thing here I want to show you is we do have this monitoring portion as well, which is the fifth and last step. So if you click on here, monitor, as you can see on the navigation bar, it will open another tab over here. Just let me log in quickly. Okay, so this is a online monitoring system. There's actually quite a lot here we didn't run. I'll just open one just to show you how it looks like. So in our monitoring system, okay, it is based on the industry's OEE, or we call it the overall equipment effectiveness. Okay, so the OEE will actually break down into your availability, performance, and quality. Okay, so as you can see here, availability is actually tracking your actual runtime and the available runtime. Okay, and then performance will be tracking your cycle time, okay, average and ideal cycle time. And for quality is actually tracking your productive cycles, which will break down into non-productive, completed cycles, which breaks down into productive or non-productive cycle. Okay, so you can just scroll down briefly. You can actually see the OEE trend. It will show you in a graph format. Okay, so you can actually select your target OEE. So for this particular case, it's about 80%. Okay, so you'll be tracking every hour. You can also download this graph via the 3 different file formats, but the most commonly used one will probably be the CSV format. So you can actually download the graphs and then can create like a list and then maybe submit it for comparison or something like that. And then for availability as well, you can see the total available runtime will break down into actual runtime versus your total downtime. Okay, it's also by, you can actually see the graph as well, the pie chart over here, and then it will show you the reason of the downtime. Okay. And then in terms of performance is the cycle time. So you can see your minimum and maximum cycle time, your ideal cycle time that you want it to be. You can actually set your ideal cycle time. Then it will let you know your average cycle time. Okay. And then there's a graph as well, which you can also download via CSV. And then in terms of quality as well, you can see the productive cycles versus the non-productive cycles. Okay, and there's also a chart as well that you can actually download. And then you can also see incidents, errors, warnings, and notices as well. Okay, and then we do have event counters. Okay, and then we have this thing called application matrix where you can actually see how many boxes per minute, minimum, maximum. Okay, so there are also other features, for example, like alerts. Okay, we can set up alerts. Okay, so for example, if this group of people are in charge of this particular application, okay, and then you can set an alert. Okay, then when this error happens, for example, the workpiece drop. Okay, so based on this error, okay, you can either include everyone within this group to receive an email, or you can just have the project manager receiving that email that this particular error happened. Okay, and then you also have like shifts, so you can create shifts as well. For example, so you can actually track, for example, day shift and night shift. So you can actually track the overall the OEE. For example, the day shift and night shift, if it's running at the same OE percentage, or you can see how come my night shift is running better than my day shift, for example. Then you can actually break down all this information to check what's actually wrong with the night shift or the day shift. Okay, so this is actually how the monitoring portion works. Okay, so I think we have some time now, so I just want to show you based on this particular setup that we have. Just gonna show you how actually the robot actually run based on the inputs that we have keyed in. So I'm just gonna run this actual application now. So you can see it. So you can see here number of parts picked and number of placed parts. Okay. Sorry. Okay, so you can see now it's actually running. So you can see it's following the flow after it picked from infeed. Okay, and then it's doing the blowing. Okay, after blowing, they will you do the loading of the gripper. Okay, and then unloading. So I do not have actual door, but I have a tower lamp over there. I'm not sure if you can see. So the red color means the door is closed, and then if you see amber, that means the door is open. So as of now, you see the door is closed. It's waiting for the door to be open at amber light. Now you can see, and then it will go in to do a blowing of the parts. Okay, and once it has cleared, then it will actually unload. Okay, and once unloading, it will rotate and then do another cleaning again. After cleaning, then it will load the parts in. Okay, then you'll move out of the machine and then wait for the door to be closed, which is the red light, and then place the parts back into the outfit. Okay, we are using the same infeed and outfit, so yeah, we're placing back to the outfit, and then the actual thing will actually repeat. Okay, and then the other two parts will be the exact same thing. So as you can see, based on all these movements, okay, we have zero programming at all. As you can see, all we did was just input all the numbers into the application portion, and then deploy will automatically plan out everything like as what you see from here itself. Okay, so I think we have some time for some Q&A. So I think, so I think I'll hand it over to Shiv, to Mels.
Okay, thank you, Branson. So thank you very much for the demonstration. What we'll do is this, I'll just take the next 5 minutes to quickly introduce Mels, and then we will have the Q&A answered as well. So in the meanwhile, if you have any questions, I request all participants to put it on the chat. Let me just take a couple of minutes to introduce Mels and where we come from. Yep. Okay, I hope my slides are visible. So just a quick background to Mels. So we are an engineering and technology company. We started in 1995 and we have about 165 employees. We are based out of Chennai in India, and we have our branch offices across the country and in all the major metros, as well as we have resident sales and support engineers to work with our customers across. As an organization, we work on 3 business units. One we call the agency, representing electronic assembly and test repair products from other countries in India. We work on industrial automation, and I think this whole tie-up with OnRobot is for providing value-added solutions in this area on the robotics and future automation solutions. And of course, we have an internal electronic design team working on different type of testing solutions, as well as for mill grade and aerospace related solutions. So this is our office in Perungudi in Chennai. We are located on the OMR, and we are an ISO certified company for quality management system, as well as for information security management system. So while Mels, we have been offering industrial automation solutions for over 2 decades now. We've transformed ourselves into an Industry 4.0 solution company, and you would have seen this typical slide on the 9 pillars of Industry 4.0. So Mels, at the moment, we operate on 6 different pillars of Industry 4.0. We provide solutions for IoT in the areas of energy monitoring, all type of data capture. It could be on-premise or cloud-based solution as well. We have a complete team providing cloud computing solutions for anywhere, anytime data for remote monitoring and to provide notification alerts. As always, we've been doing system integration. We work with weighing, batching solutions, electromechanical solutions, and then we integrate on the IT and OT, where you may have PLC control systems or any other CNC based systems, and then we integrate it to the system. Your automation line along with your ERP or your production planning control. We also provide solutions for simulation, which could be for process modeling or process simulation, along with a digital twin. The other area that we operate on is on the big data. We provide complete historians, traceability, genealogy related solutions. And on robotics, of course, we provide the complete turnkey solution, including robotic arms, as well as end effectors and robotic solutions like DPLOY, which will allow us to implement robotic solutions in your factory. On the industrial automation side, we've got a complete team handling mechanical, electrical and control systems, as well as on the IT OT area, providing an end-to-end solution for you and your customer users. On the robotics itself, Mels, we work with different partners for robotics. We work with Epson, typically on the Ascara robots. We are the authorized partner for Doosan collaborative robots in India. We work with Yaskawa for the industrial articulated robots, and we are a partner of OnRobot, providing all their solutions, including the different type of end effectors and tools like the DPLOY. So I'm not spending more time on the different OnRobot products, but as Niels explained, OnRobot has the complete suite of end effectors, which can go on to collaborative robots or other industrial articulated robots, and they are non-pneumatically operated. They're all completely electrically operated, giving complete control for you in terms of, let's say, if it's a gripper, then you have control over the stroke length, you've got control over the force. If it's a vacuum gripper, it still operates without pneumatic air. We have an electric screwdriver. We also have soft grippers to handle parts that are of different shapes. Also, there's a sander for finding and finishing, surface finishing type of applications, right? And with Doosan Robotics, MELS is the partner for Doosan Robotics in India. We have implemented several projects for Doosan, and Doosan comes with one of the widest range of cobots available in the market. There's a H series offering 20 kg and 25 kg payloads without close to about 1,700 reach at the max. We have an M series, which is more for special applications, very high accuracy and torque force sensing. There are 4 different models available on that, right from 6 kg all the way to 15 kgs and a different reach. And we have the economy series of the A series, which is used for fast, quick applications with both a 5 kg and a 9 kg model. A small video of some of the projects that we have done. So on the robotics itself, there are different type of applications. You could see even very simple sweets are being picked and placed within OnRobot grippers. We've done palletizing solutions. We also build all the end effectors that needs to go with the robot. So it could be, let's say, the auxiliary equipment. So you may need conveyors, you may need control panels, you may need some jigs and fixtures that needs to go along with the solution. So MELS, we are able to provide all this as part of the delivery of our solution, including all the machining and different type of auxiliary equipment that will be required. Apart from robotic solutions, we also build some special purpose machines which are very special applications. It could be with vision system, it could be with turntables, it could be large conveyors, it could be applications for supporting the robot in terms of providing in-feed or out-feed conveyors or jigs and fixtures. MELS is also working with this company, Visual Components. We are their partner for them in India. This enables us to do process modeling, process optimization, and also set up a complete digital twin for you. Right. With that, I will end the presentation for MELS, and I'd like to open the floor for question and answers. Any of you have any questions, feel free to unmute yourself and ask your questions. Yeah. Thank you. So any of you have any questions? So in the meanwhile, I'd also like to mention that we have a OnRobot deploy kit available with us at MELS. And if you would like to see a demonstration of the product itself, feel free to contact us and we will be able to demonstrate it to you. You could really get a hands-on feel of how it works and how simple it is to do applications like the CNC machine tending or palletizing application or pick and place. We should be able to demonstrate that to you.
Yeah, I might just add on to this, Shiva. I think it's a very important message to bring across. So in the beginning, I was talking about different kind of software solutions that are out there that a lot of companies are using to kind of replicate what an application might look like if you set it up. But the thing with Deploy is that you can actually, within a day, you can actually set up a robot with some grippers and do a hands-on application that actually shows you exactly how it runs. So it's very simple to do, very simple to show, and does it work or doesn't it work? So that's one of the key benefits, I think, also for Deploy that you have.
Yeah, I fully agree. And in fact, when you look at a typical application, most robotic projects, like we've been implementing solutions for our customers, and this brings down the total deployment time Let us say when you have new models coming up in your shop floor, and the whole concept of robotics is also changing now, where you don't expect a robot to be installed and then it's just going to handle one part. With the high amounts of variations that customers are asking, a typical machine shop may require, let's say a machine shop owner, he would want to have different type of products that are to be manufactured, and every time you can't call a robotic programmer to come and spend time in programming it, handling different type of objects and saying, okay, this is how it's going to work. With a tool like the Deploy, it's going to be pretty fast for you to make the modifications with no special expertise. As Branson was demonstrating, you have a simple web interface. You go and pick and choose, give the configurations. And again, you don't need an external teach pendant or a programming software. You could use the web screen by itself and then move the robot into different positions. Or if your robot supports hand teaching, then you could do that as well. Teach the positions and then ask it to turn on and turn off signals. Use the different OnRobot grippers to do the gripping. And then it's that simple to deploy a new application. And I think that's the major value add that customers can get.
Yeah, and it's basically for industrial robots, right? Because they are still very complex to program, and it takes a lot of time of doing programming of industrial robots. So as I mentioned earlier, then the next brain that will be added to deploy is Yaskawa, which you guys are doing as well. So hopefully within the next couple of months that will be available, and you guys can start showing on Yaskawa as well for those clients that might be interested in that. So so just to repeat that as well.
Oh, I am Dheeraj. So is there a one-time cost, or do you have a subscription cost for the license or any such thing?
Yeah, it's subscription based. So basically the way it works is there's a first year subscription which is basically full price. Second year onwards, it's 50% of the existing license cost. But one thing that is also important to mention is that if say you have I don't know maybe 20 different products you're working with, so you can actually set up your application for all these 20 products once you have deployed. If you don't add on anything, or if you don't change anything after the first year, so the next 3, 4, 5 years, you basically run the same 20 products. You don't actually need to resubscribe the second year. You can keep on running forever without resubscribing. But what you cannot do if you don't have a valid subscription is you cannot change anything, or you cannot use the monitoring tool either. But if it's the same products you're working with, the same application, you can basically running without having a valid subscription.
And the software will be, say, after a couple of years, software will be auto updated. That is updates of the software.
No, so there'll be regular updates. We basically have updates once a month or once every 2 months or so at the moment. So same thing, as long as you have a valid subscription, any updates are free. If you don't have a valid subscription, you can't update. But if your application is already running, there's really no need for you to.
Okay, thank you.
Sorry, Sathik here. Is it possible to add a new customized or configurable interpreter with this system?
Sorry, once again, you're hard to hear.
Yeah, is it possible to add one more customizable reconfigurable interpreter to the system? In the deploy system, we can. Is it possible to?
Sorry, are you saying is it possible to add on a customized gripper? Is that what you're trying to say?
Yes, sir. Yes, that's right.
Okay, so as of now, for deploy, we can only use products that are tied down to OnRobot. So this is a strategic plan. So maybe maybe I don't know, 5 years down the road, 10 years down the road, once we have captured the market under deploy, then we might be able to add on customized grippers. But as of now, it can only be used with OnRobot products.
Okay. Can we download the program after doing the deployment of the system? For the
There is
academic
no way.
purposes, we can.
There is no
Yeah.
way because you will not be able to see any program anywhere. It's all actually from the cloud, and then it just does all the path planning, everything from the cloud, and then just saves this particular file into the OR base. But you can only call the program. You will not be able to see any programming lines at all. So there's no way for you to get it.
Okay, thank you.
Maybe just to add on to that, so there's a reason for that as well. I mean, we have been working on deploy. We launched the first version, version 1 in January, but we actually been working on it for the past 4 years. So there's a lot of R&D, a lot of man hours gone into this. So we do not share how we are doing it, how the programming is done, and how we're doing optimization of the path planning and cycle time and so on. So that's, let's say, that's a key reason you won't get access to the software. And the other reason is that once, I mean, deploy is basically made to optimize everything, optimize path planning, optimize cycle time. So there's no need for you to go in and make any changes. That's the whole reason. We don't want you to start doing programming. Basically, you key in the figures, the whatever is needed, and the rest is done by deploy. Any other questions on deploy or otherwise?
And yeah, just to add on, so while it was demonstrated to show the a CNC machine tending application, like what Niels showed in his slides, deploy can also be used for, let us say, a palletizing application. So it out of the box, let us say, there are different type of cartons or boxes that you need to palletize. We could use deploy to easily configure them on the screen to say what is the pattern to follow, how many layers that needs to be set up. Again, you can configure an in-feed, and it can automatically write the program for the robot and work along with it to pick and place the cartons and boxes onto a palletizing. So again, palletizing becomes extremely simple, and the same solution can be used for that. So that's another advantage of deploy. So it's not only a machine tending solution, right?
Yeah, correct. And in fact, once you have deploy, whatever deploy offers is all included. So I know this might not be relevant for most of you, but you could, in theory, do packaging for 6 months, and then you can move it to another robot and do palletizing for the next 6 months. Everything is included, all applications, the monitoring tool, everything. So it's basically very flexible in the way you want to use deploy in your manufacturing.
Good afternoon, Murali Das here. I have a question here. Hello, can everybody hear?
Yes.
Please go ahead.
Yes,
please
PA.
go ahead. Yeah.
See, we are looking for a vision-based inspection and packing. So what are the options available? What are the, we want to explore the robots involvement in this.
Shiva, do you want to take that? Or?
Yeah, so as of now, what happens is this: the vision-based inspection would have to be done as one section, right? So what we will do is as two parts. So one will be the vision inspection itself. The vision inspection, after it does, we can still give the OK signal, like it's equivalent of saying the part is ready for the pickup and palletizing. So that part can be done with the deploy, which will help you do the palletizing. And the inspection part itself can be done with whatever camera that we need to do, depending on the type of part. I'm not sure of the application. It could be a single, let us say, when you say inspection, again, whether it's for identification or a quality inspection, I think we will need to decide the type of application, and then we can send back the signal to the OnRobot deploy then to be able to do the palletizing. So that's very much an option that's available.
I just need to correct you here. That's currently not an option. So first of all, our vision, the OnRobot vision system is not yet implemented with deploy. That will come likely in, I think, Q3 this year. But even then, how that's going to work and what we're able to do, whether we can do inspection and connect that with palletizing, I can't say yet. But once the OnRobot vision system is integrated, an inspection in itself, yes, we'll be able to do with whatever our camera is able to do, but how to connect, for instance, with palletizing and so on, I cannot say yet. I also think it's important to say that inspection is quite a wide field. The current version we have with OnRobot, it's a 2.5D. It's not 2D, it's not 3D, it's 2.5D. We do some inspection, but there are some limitations to it. So it kind of depends a little bit on what kind of inspection and what product you're inspecting and so on. But I also know Mel's have working with different suppliers of cameras and so on, whether you need 3D or 2D or whatever. So I guess you can talk to them about the specifics of that. But just to say deploy and vision, not working at the moment. It's coming later.
All right. Any other questions? All right. So if there are no further questions, I would I think we'd probably then conclude, Niels, unless you have any other comments to make.
Not really. I think we kind of explained, let's say, the value proposition of deploy. Just to kind of maybe reconfirm or make a restatement on where I think it's particularly beneficial. As I said, high mix, low volume, a lot of changeovers. That's, I think, especially in India, things like palletizing and CNC machine turning currently, I think are the main applications where I think it will make a huge benefit to manufacturers and particularly SMEs that are, let's say, currently not able or willing to do automation because of the complexities and the lack of flexibility and so on. So for those of you that that are a bit worried about going into automation, I think this might be a solution for you that can really benefit you and make things fast and easy.
And yes, to add on, as I said, we have a deploy demonstratable unit available with us at Mel's. So if there's any questions that you have, feel free to reach out to our team. Again, on OnRobot website, there's a OnRobot Learn section available. You can learn more about the product and the information, and feel free to reach out to us if any questions you have, and we will be more than happy to talk to you and see how we could offer a solution. Yeah. And, yeah, thank you once again. Then thank you very much, Niels. Thank you, Branson, and I thank all the participants for their time today. A recording of the same will also be sent to you, and it'll also be available on our LinkedIn event page. Yeah. Thank you very much.
Thank you so much.
Thank you.
Have a great day. Bye.
Bye bye.
Bye.